Here we have our now familiar two-dimensional grid. This grid is made out of a number of columns and a number of rows. There is nothing new compared to the previous tutorials with cellular automata. What is different in this case, however, is going to be on the main attributes that we're going to use to change the color of our tiles. For the first time, these colors are no longer discrete, 0 or 1, but instead are going to belong to a color scheme that are going to go from no saturation to full saturation of a particular color. So how do we calculate those values? We're going to focus on the top left corner of each of our tiles. These values are calculated based on the position of a particular tile in the grid, multiplied by the resolution. So let's focus on this first row only, just for now. So here, let's calculate the different values in the x-axis, as the y-axis is always going to be 0. The first value in x is equal to the position of the column where it is, counted as index 0, multiplied by the separation between two different tiles, which is given by the hyperparameter res. In other words, res represents the dimensions of a square. Let's suppose that is 64. That means that multiplying 0 by res is going to give us 0, so that is the coordinate in the x-axis of that particular tile. We move to the second column, which is at the number 1, and we multiply res by 1. Res is 64, which means that we have moved 64 pixels, or res, to the right. We continue the process, and eventually we are going to end up with different values for the different tiles in the system. The position of the tile in a row in the x-axis is going to be the input to a helper function, a mathematical function, that is going to map the value in x and return a particular value in y, which in our case is going to be represented with color. So let's see. Here we have the function x modulo 255. For those of you who may not feel familiar or that comfortable with the concept of modulo in programming, modulo is very similar to a remainder. There are some subtle differences when it comes to negative numbers, but for Python, the modulo is the remainder that also works with negative numbers. What's a remainder? Basically, if I give any number x that is less than 255, the return is that number itself. You may feel familiar with the use of the modulo from the cellular automata tutorials, because we use it in order to calculate and wrap around the world from one edge of the screen to another using the principle known as the flat torus. Let's work with a simpler example. Let's suppose that I give you 2 modulo 4. The operation is as follows. I take the number 2 and I divide it by the number 4. 4 doesn't fit in 2, so the answer is 0. 0 times 4 is 0, and then I subtract it from 2, which is 2. The same happens with the number 3, but with the number 4, things change, because 4 divided by 4 is equal to 1. 1 times 4 is equal to 4, minus 4 is 0. So notice that the return resets the values back, so that they're always within the range that goes from 0 to whatever number you have here, minus 1. Okay, so now that we have that out of the way, let's see how the process works. Let's pick the first point. The value in x is 0 times res, which is 0. 0 modulo 255 returns 0. In the second example, we have the second position in the columns, which corresponds to the coordinate 1 times res. And depending on what the value of res is, it may be that res modulo 255 returns the identity res, or it returns a rescale value relative to the modulo 255. If we repeat the process many times for every single column, we are going to change the color of each of the tiles in the process, and we're going to end up with something that looks like this. The resolution and smoothness of this gradient is given by the variable res. The smaller the increments, the more resolution we're going to have between pure black and pure white. However, this is not the only function we can apply. We're also going to use sine waves. Let's go to Desmos. So the signed function of a variable x will always be defined within -1 and +1. We are going to add 1 to that value, and we're going to get rid of the negative numbers. The range has been moved to cover only the domain of the real positive numbers. But we can do more than that. Because these values will only give us colors between 0 and 2 of saturation, we need to multiply it by half up to 55, which is, in this case, let's just leave it at 124. And what you can see is that the values now bounce between 0 and a maximum of around 255. I guess that it should be 127. There it is. Now we have values that go from 0 to 254. That way, we don't exceed the values accepted by each of the color channels, which goes from 0 to 255. If we do so, we're going to get an error. Okay, so it seems like we are ready to proceed. So let's go to Pygame and Python and let's implement this algorithm.